So let me now introduce Katrin Millock, who is a senior research fellow in economics of the French National Center for Scientific Research, CNRS, in Paris. She is also associate professor at Paris School of Economics. She is a specialist in environmental and resource economics. Her research has been devoted to evaluating the effects of air pollution taxes, and her current research is centered on climate change and development, and in particular, what is the topic of today, climate-induced migration. Katrin, the floor is yours.
Thank you very much, Lisa. I'm very happy to have been invited to this session. I'm presenting joint work with Theo Benonier and Liz Taras. As you know from Laurie's talk, climate change will have huge impacts on the distribution of population and migrations. And in particular, the World Bank's groundswell report that you may know predicted that there could be between 31 and 143 million internal migrants by 2050. And this was based on a study only in 3 regions: Sub-Saharan Africa, South Asia, and Latin America. And this is one of the pieces of evidence that we have that climate change, or increasing temperatures, changes in precipitation patterns, and extreme climatic events will affect migration. But as was also underlined in the previous presentations, it's very difficult to establish general results on the relation between climate, weather, and migration, in particular for international migration. So if we look at these aggregate macro studies that Flor was mentioning, typically they don't find any general results, but they find what we could call conditional results. So they can find effects if you condition on the fact that a country is poor or agriculturally dependent. And then, for instance, these academic studies have found that increases in temperature would increase migration flows or even reduce them. And in particular, though, several recent studies have emphasized an agricultural channel. That the main mechanism, if we think about poorer countries that are the most affected by climate change, are the most dependent on agriculture, in particular for livelihoods. One of the main channels, in addition to conflict, should be an agricultural channel. And despite this, no work has really included the role of irrigation in these macro aggregate studies of this nexus. So this is what I want to talk about the next quarter of an hour. I want to talk about irrigation. So this is the main means, right, that human populations historically have been able to safeguard and increase agricultural productivity. You may think about ancient Mesopotamia, Egypt, ancient Peru. Currently, around 20% of cultivated land is used for, is irrigated. But it corresponds to 40% of world food production. So what I really want to emphasize with those figures is only that it drives home the importance of irrigation, right, for food security and for livelihoods, and hence that it should have an impact on migration. And irrigation, as we know from the agronomic field, has improved yields in a consistent manner, so it has reduced poverty. And this is not doing justice, of course, to these studies, but if I were to summarize, the agronomic literature basically works through 2 mechanisms. It increases soil moisture, but it also has a cooling effect on local temperatures. And in this sense, irrigation is crucial for understanding agricultural climate impacts, and yet it has not been accounted for in the literature using these global data, aggregate data on international migrations or urbanization rates. There is work at country level, and there is some work at the international level that looks, that controls for groundwater access, but not for irrigation as such. So this is our very simple objective in this paper. It's to look at how access to irrigation can affect the temperature migration relationship. And in doing so, let me preview our results for those who have to leave. We find that access to irrigation can be complementary to migration. We do find, as a lot of the recent studies, that rising temperatures will not increase migration, but will in fact reduce migration rates. So this is what has been referred to by Flor and by Laurie as either trapped populations or liquidity constraints, which I come back to. So we find that impact, but when we add irrigation access, the interaction with irrigation access, we find that having access to irrigation attenuates the negative impact of high temperatures on internal migration in low-income countries. But we find very little evidence of irrigation being able to offset the effect of higher temperatures on international migration. So these results are relevant, in particular because rural-urban migration is considered as the most likely response to climate change. So our results relate to this literature that has been mentioned about liquidity constraints. Here I'm only giving some of the references to these aggregate macro papers. It also relates to the earlier work by Richard Black and Neil Adger on trapped populations, because we will find the similar result that rising temperatures, as one aspect only, of course, of climate change, does not increase migration, but depresses it. And finally, our results are complementary to some existing work that looks at either smaller areas, like one state of India, or that looks at internal migration in one country, and finds that having access to irrigation actually reduces internal mobility. So the data, a few words on that. So we are working at a macro level. We're using the World Bank's Global Migration bilateral database to capture long-run migration trends. So we're going to study decadal migration rates from 1960 to 2000. For internal migration, we're going to use a proxy that's obviously falling short of capturing all internal migration. We're going to look at the UN's measures of urbanization rates at a country level. This is obviously only a proxy, as we know that internal migration takes many forms, not only rural-urban migration, but also rural migration and urban-rural migration. But this is what we'll use in line with this aggregate macroeconomic literature. We will use temperature and rainfall data at a gridded level, aggregated up to the country level by population weights. What's important to note is that we're going to use these weather factors we're going to average the weather during the growing season, in particular the maize growing season, as maize is one of the most important staple crops for calorie intake for the human population. And then we're going to add our main variable, which is the area equipped for irrigation. And I'll come back to that one. And we're also going to add some other data on state capacity. And in the end, though, what we're doing is we're going to keep a sample of only poor and middle-income countries, excluding the OECD countries. So we're going to have a final sample of 28 low-income countries and 84 middle-income countries. And let me show you part of that, the statistics. So as we know, the immigration rate from poor countries is only around 1.3%, or in our sample, the decadal migration rate, whereas in middle-income countries is 2.8%. And the share of urban population is around 19% on our sample in the poor countries and 42% for the middle-income countries. And I just wanted to flag this, that then the share of 1960s cropland that's equipped for irrigation, because this is how we're going to control for irrigation. We're going to look at land equipped for irrigation historically. So in 1960, before the period that we're going to study for migration. So in poor countries, this is a little less than 4% of cropland that's equipped for irrigation, whereas in middle income, it's around 13.4%. And then another fact that you can see just from the summary statistics is, of course, that the poorer countries are located in the tropics and in general have a higher temperature, average temperature, than the middle income countries. And they also have a lower rate of precipitation. So in our sample, when I say poor country, you have to think that these are very poor countries. It's countries like Afghanistan, Burkina Faso, Mali, Malawi, and so on. I want to focus a little on what we're doing then. We're adding this measure from Siebert et al. On the area equipped for irrigation. So what we're doing is we're not looking at areas actually irrigated. We're going to control for access to irrigation. So we're going to view irrigation as fixed infrastructure. You have the possibility to use irrigation. And we're going to compare two countries with similar climatic conditions, similar weather fluctuations, and see whether having access to irrigation modulates the migration response. So it's important to know how we measure this. So in Siebert et al., basically, what is counted as area equipped for irrigation is area with equipment for full or partial control irrigation. So this is surface irrigation, the typical furrow irrigation that you saw in the previous picture I showed, or sprinkler irrigation, or even more modern forms as drip irrigation. But it's also equipped lowland irrigation. So this is typically then either wetlands or flood deltas. And it also includes spate irrigation, which is the most ancient form of irrigation that has been in use for 2,000 years, and that is still very much used in certain parts of the world, like the Horn of Africa and in Pakistan. The measure doesn't include rainwater harvesting, though. And then what we do is we put this in proportion to the cropland, obviously. And for this, we use the historical database on the environment. So we get a measure that is the proportion of the cropland in each country that is equipped for irrigation. And here I show you the map from 1960. So we're going to study how long-run migration rates, both immigration rates and urbanization, change from 1960 to 2000. And we're going to control for the irrigation equipment in 1960. And this is the map. So the first thing I want you to notice is the great variability here, right? And there is another fact about irrigation, that 3/4 of irrigation is located in the developing world. But the point here is, obviously, if you look at Africa, you see, well, you know from statistics, maybe from elsewhere, that Africa has the lowest irrigation rate. The average is around 5%. But there is large variation. So you can compare, for instance, Somalia, Egypt, to some of the other countries that have less share of cropland equipped for irrigation. And the point that we're drawing on is really, if you compare two countries that share similar climatic factors or similar weather fluctuations, so they may be at the same latitude, for instance, or be neighboring countries. So you could compare Malawi and Mozambique or India and Pakistan that would suffer similar extreme heat waves, but have very different access to irrigation equipment and very different shares of land equipped for irrigation. This is what we're relying on in our analysis. And a few words about our empirical strategy. As Floor's work, this is an econometric analysis. We basically regress emigration rates and urbanization rates on the average weather, both temperature and rainfall, over the past decade. And then we interact the weather with irrigation and also with this dummy variable indicating whether whether a country is poor, in the sense of being in the lowest quartile of the income distribution. And we control for the income level of the countries, country-specific characteristics, as well as regional and poor country time trends that are aimed at capturing part of what could determine migration trends. And I'd also like to say one word about identification of the role of irrigation in our work. So basically we know, right, that there are several channels for the relation between rising temperatures and migration. One of the most notable ones is conflict. There are health impacts. There are impacts on labor productivity as well as total factor productivity. And we remain agnostic about that. We use a reduced form approach where we measure the total effect. But when we look at these interaction effects between temperature and rainfall with irrigation, we know that irrigation as such would only dampen the effect for the agricultural channel. So we are rather confident in that way that what we're capturing is irrigation's modulating intervention for the agricultural channel itself. So what do we find? What are our results? So we can confirm the results of this literature, namely that in general we don't find an effect. But for poor countries, for every centigrade increase in temperature, there is a reduction in migration that then would be compatible with liquidity constraints operating, meaning that as rising temperatures make people poorer, they can no longer pay for migration, in particular the more costly one, that is emigration. We don't find any modulating effect of irrigation on emigration rates, international migration. When we study urbanization rates, each centigrade increase in temperature, all else equal, would reduce the urbanization rate by 6.7 percentage points for a poor country that has a median level of 1960 irrigation. And if we then compare that with a poor country that would have one standard deviation, higher share of cropland with access to irrigation, that reduction would only be 4.6 percentage point. So we do find that irrigation attenuates the impact of increasing temperature on urbanization rates in poor countries. But note that the net response is still a negative effect, a reduction. So populations are to some extent still trapped, if I may use that word. Then we do something else in the paper. Instead of having this indicator for a poor country, we focus on agricultural countries. So measuring countries that are in the highest quartile of value added from agriculture over GDP. And we can find a cushioning effect then of irrigation for temperature, both for urbanization and for immigration rates. So basically, in some sense, then, a lot of the countries in our sample, they are both poor and agricultural. So it's rather reassuring to find that this effect holds for either if we use the dummy variable indicating poor countries or if we use a dummy indicating agricultural countries. All the more so since we believe that irrigation works by attenuating the impact of rising temperatures on the agricultural channel of migration. We control for institutional factors, and one of the main ones would be that some states have the capacity to provide safety net programs or any other social safety to their populations. We do this by controlling for government final consumption as percentage of GDP. We find that our results are robust to this, but slightly less significant at a statistical level. We also control for political institutions of the country, because recent work has found a link between autocratic regimes and irrigation potential. And it is also well known that more autocratic states or centralized states have been able or were investing more in this huge infrastructure for irrigation. So we control for an index for autocracy and democracy. We take the average in the preceding decade to when we're measuring irrigation capacity, which was 1960. And it's robust to this. And we do some other exercises in the paper controlling for weather factors in other crop seasons. I said that we're weighting temperature and rainfall during the maize crop season, but we're doing this also for weather factors according to the rice and wheat growing season, and also annual 12-month weather. We're also doing other checks, such as excluding the small island states. So just to sum up, in a nutshell, this paper then basically speaks to this larger literature using aggregate data at an international level for both emigration rates and urbanization rates. And we add interactions with irrigation as infrastructure, access to irrigation in 1960. And we find that irrigation can offset the negative effect of higher temperatures and urbanization. It intervenes. It doesn't offset the entire negative effect of higher temperatures, but it does indeed modulate the relation. So it's important to account for it. We fail to find similar evidence for the modulating role of irrigation on international migration. And this is, of course, very rough work in the sense that we're basing ourselves on these aggregate statistics on a panel of global, on a global panel of countries. So future work should indeed go deeper, looking at more detailed micro-level data in a specific country. And the interesting piece with this would be that then you could really start studying how other adaptation strategies, how irrigation as an alternative adaptation strategy to migration would vary and interact with migration. And this is something that we have left out of this paper. This is why we study access to irrigation only, not investment in irrigation as such. We look at the historical access to irrigation equipment. So this opens up a rich research agenda that I'm happy to address more in the question and answer session. But thank you very much.
Thank you, Katrin. Thank you. Again, very consistent study and complementary to the others in terms of the approach that you take, that is very macro and very, I think, stimulating in terms of policy implications.